Hello everyone, and thank you for joining me for this webinar on optimizing your 3D surface finish using GibbsCAM. In this webinar, we're going to go over the advanced 3D workflow from choosing a tool, to choosing geometry, to choosing the correct toolpath strategy that's going to give you the optimized surface finish for the geometry of that part. Looking down this list, you can see we're going to cover some strategies, the applications for those strategies, optimizing your lace cut, use of Constant Stepover. We're also going to cover saving and reusing processes, and I'm going to cover toolpath simulation, and I'm actually going to show that throughout the demonstration today. Here I have a cavity on my screen that I need to rough and finish. The first thing I'm going to do in GibbsCAM is create a tool. There's a set of tiles over here on the left-hand side. The top are my tool tiles, so this will be a list of my tools. Below that is going to be a list of my processes. Let's go ahead and start with a tool. Really easy to define. Here's my roughing end mill, finishing end mill. You can see there's a lot of different shapes, all different kinds of end mills. We do broaching and probing. If this was a lathe, we'd have a set of turning tools here. If you have any questions, or if you do broaching or probing, or if you want an example on a lathe, please feel free to reach out. We'd be more than happy to help you. Okay, so I have a 1/2 inch tool. It's got a 2 inch length of cut, but it's only sticking out of the holder an inch. So let's change that. There we go. It's a little far, but for this demonstration, it's going to be okay. So now that's going to be my tool number 1. I want to create a finishing tool while I'm here, and that's just going to be a ball mill. So I'm just going to select ball mill, change that to a 1/4 inch. Now that I have my tools, it's time to create a process. For this demonstration, we're going to use Advanced 3D. Now there's a couple different ways to get there. We can just drag down the tool to that tile, and it'll automatically bring up our process list. Or we can double click on that tile, select the process, and then GibbsCAM will automatically show me the appropriate tools that I have that I can do that process with. So for this one, for the roughing, I'm going to go ahead and pick that 1/2 inch. And here we have our process window, and there's tabs that we work from left to right. Here we have our surfaces, the mill feature, some options, entry and exit moves, and our boundary. I'm not going to go over every one of these or we'd be here all day, but I'm going to go over the big stuff just to kind of help you guys see the workflow and how to get started. So the first thing I need to do is select the model, which is easy enough. So there's the model right there. That's what I'm going to machine. The next thing I need to do is I need to set the minimum and maximum for my Z, so how far down I want it to go, and what the maximum is I want it to go up. Also, I need to define here my retract and my clearance planes. So in GibbsCAM, again, really easy to do. I'm just going to click off of this so we can see it. We can see that my Z here is at the top of the part. So I know that my maximum Z is going to be 0. I'll just give it a little bit of room, just clearance, just to be safe. Give it 10 thousandths. And then the negative part, how low I want it to go, I can just hold down the Alt key. You can see if you see my cursor here on the screen, if I hold down the Alt key, it turns into a square. It says it's looking for input. So I can hold down my Alt key and click on this bottom corner, and it automatically pulls up the lowest point on that corner for me. So the next thing I want to do, I'll click that model again just to make sure it knows what we're machining, is our Z step. I know it's about 2 inches down. I got a 1/2 inch cutter, so half the diameter. So we'll just go 1/4 inch, and all I have to do is click do it. So here we have a representation of the path that the center of the tool takes as it's roughing the part out. So let's go ahead and simulate this toolpath. Now there's a couple different ways to do it. The first one I'm going to do is I'm going to just simulate this operation. Go ahead and press play right here. Geez, we all wish our machines worked that fast, right? So then there's that roughing that I was talking about. So, this is great. The problem is, with this 1/4 inch ball mill that I really want to do that step over with, it's really asking that 1/4" cutter to hit these steps, these really high steps, and we're going to get cutter whip, maybe even break the cutter. It'd be terrible. What I want to do is I want to decrease the size of these steps, which is pretty easy to do, right? You saw me change the Z step down. So if I made a smaller step down, let's say 50 thousandths, and hit redo, if we look up here in our window, there's do and redo. I'm gonna go ahead and hit redo. Now we see there's a lot more toolpath there. So let's go ahead and look at the simulation for this. So this is great, right? We have that small step over, which is gonna really kind of take that pressure off that 1/4" ball. The problem is your machine never runs this fast, right? We're looking at something like, I don't know, depending on the machine you have, geez, that might even be fast. But the machining time is really gonna take a long time. So you either put a lot of pressure on the tool, or you machine out with very small steps to take that pressure off. In GibbsCAM, we can address this with what's called adaptive pocketing. What it's a tongue twister. What adaptive pocketing will do, it'll actually do 2 different steps. It'll do the main step, which we're going to say is going to be 1/4", and then the fine step is going to be 50 thousandths. It's going to be on this mod. So if I hit redo, it would replace this process with the new process, which is adaptive pocketing. If I hit do it, it's going to create a new process over here on the right-hand side, or a new operation on the right-hand side. Now that we have the toolpath calculated, let's go ahead and take a look at the simulation. Actually, you know what? I'm going to play it just a little bit slower, and you can see what it's doing. See, it's doing that big, deep cut. And then it's going to come back and reduce that. See how it works up and then reduces that cut? So you're not having the tool rough out the entire pocket to decrease the number of steps. You're just getting rid of those big steps. This is a really great and fast solution that will increase your surface finish, because it's going to decrease the amount of sideward pressure, and it'll just take a lot of just overall pressure off of your 1/4" ball mill or your finishing ball mill. That's adaptive pocketing. Let me move on to my next example. Let me just go ahead and hide a couple things here. My work plane and my origin, you don't need to see that. Okay, so this is the part we're going to use for what I call lace cut, or that's not what I call, what GibbsCAM calls lace cut, which is just a back and forth that's projected onto the part. So just like before, I'm going to just go ahead and pick my tool and then drag it down, and then double click on Advanced 3D. We're already familiar with this, right? We already memorized this from the last one. So we're going to say pocketing, right? So adaptive pocketing, we did that one. And here's our lace cut. So when we pick up lace cut, we've got a few different options here. You can see the menu changed a little bit, but realistically, it's really basically the same. You set in your offset planes, your retract plane, your rapid plane, your Z step is right under that. And then each one of these menu items is kind of in a box down here, and it's got a title. So if you want to do down or up mill, down here is our lace style. I'm going to cover that. Over on the right, plunge area, cutting strategy, things like that. Again, I'm not going to go over one of these, but just wanted to let you know they're there. This is a new model, so I'm going to go ahead and set my 0 again. There we go. So that's where the tool is. So all of these are my rapid and my retracts are depths from the tool. So I'm just going to go ahead and use this surface here. I'm going to see what my Z step is fine. Okay, so my step over, this is where you set the distance between each line of the cutter. Right? A step over like this will give you an incredible finish. It'll probably take, I don't know, 5 days. I don't know. It'll take a long time to finish because of each line. Because we're kind of strapped for time here, what I want to do is kind of give you an example that we can see. So I'm going to make that step over really big. Again, I pick the surface and I can just hit here and click do it. Okay, so there it is. Let's go ahead and take a top view of this. There's our little view palette. Those of you who have ever seen GibbsCAM before ever, this is still in it. It's a really great feature. We all love it. So you can see what GibbsCAM did. It just took a back and forth toolpath, and as I rotate this, laid it down onto the part. So one of the things that Advanced 3D brings is advanced boundary control. So that's the last tab. Let me move this over a little bit. That's the last tab. Here's our boundary. And this is how are we going to contain this toolpath? Where do you want the tool to stop? So right now it's a part bounding box. So that's our stock basically. But really what I want, you can see the stock bounding box, the part bounding box, but here I want a silhouette. What this is just going to do is take a silhouette of that surface. Again, I was talking about do or redo. Right up here, I'm going to hit redo. And you can see that we get a much, much better looking toolpath. As we rotate it, though, you'll see there's some spikes in here. We can take care of those later on with a little bit more boundary definition. But right now, really what I wanted to show was how to really get a good surface here. Let's go ahead and look at an isometric view of this. And I'm going to go ahead and run that simulation again. Now, one thing you can notice is my stock is actually the cut material from a roughing routine. In GibbsCAM, you can actually use the resulting stock after routine as your stock for the next operation. And that's what I did here. I roughed it out. I used the result as stock, and now I'm going to go ahead and look at my, this is going to go really fast. There we go. And go ahead and look at my planar toolpath, some people call it. Again, our lace toolpath. So there it is, huge step over. But the reason I do this too is I really want to show you scallops. So I think we may not all know what scallops are. We're probably all, yeah, we know what they are. But just for those that may not, if we look at this, you can see there's these little pyramids. Everybody has a little different name for them, but we have these little lines, and what that is, that's the radii that meet in between that ball cutter coming in, and that's what gives you a bad or good surface finish. So you really want to decrease the amount of extra material when you're doing 3D machining just to get a better surface. And there's a bunch of different ways to do that. You can definitely, put this down to like, I don't know, a micron step over, and it would take forever, and it would get a great finish. There's other techniques that I want to show you, one of which is, let me go back to these surfaces. I'm going to close out this OpSim. And down here, I was talking about lace style before. If we look down here in the menu. So raster, that's just back and forth. We have radial and spiral. I'll show those to you in a second. So what I'm going to do is I'm going to go to advanced settings. So here we can do what's called cross machining. And what this will do is this will actually create a second tool path on that surface perpendicular to the one that we have, right? So it'll do this, what you're seeing here, and then it'll come back and do another one, or it could do it before. But let's go ahead and check it out. We're going to do it after. All you do is you close this out, and let's go ahead and hit redo. And this is the resulting tool path. So it's, it's a planar, but it gives you two. And let me show you in OpSim what this does. Let's go ahead and just rewind it. There we go. And then we're just going to go really fast through it. There's the one direction, and then it's going to come back and do the second. So you can see it's left with these little nibs instead of these big long things. Now you can imagine that as you decrease the distance between those passes, those things become negligible. That's one way to really optimize your lace cut, is by doing that kind of cross hatch stuff. So we were talking about, let me go back here, and we were talking about the radial and spiral. Let me show you that really quick on another model. Let me go ahead and pull that up right now. So here we have the bottom of a blow mold. What I want to do is I want to go ahead and machine this. You can imagine that if I did a parallel cut like that, that lace cut on something like this, I would really get a lot of those scallops for a couple reasons. These really steep walls, these tight radii down here as it comes across the bottom, it's just going to do a lot of weird stuff. Excuse me. So let's go ahead and I'm going to show you how to use a couple different methods to do round parts like this. Again, it all starts with dragging my tool down and selecting Advanced 3D, coming down to our lace cut. Okay, so now there's radial and spiral. I'm going to start with spiral. And you can see that if I pick spiral, I get a couple different options than if I did the raster, right? The raster, we did cross machining, all that other stuff. Here we can say where the center is and where the minimum and maximum radius is. So if you're doing like a torus or something, that's got a hollow center, this is where you would set that. We're just going to leave this here. So what I want to do is I want to select all of these surfaces down here, right? I don't want to have you guys sit here forever and watch me pick surfaces. I'm going to show you how GibbsCAM makes this really easy. I'm going to pick the surface on top of all of those. I'm going to right mouse button click. And I'm going to say, you know what? Let's just select all the faces below that one, right? So now I'm just going to hold my control key, pick up the ones that were a little tangent that I didn't quite pick, and then there we go. That's a lot of surfaces in a really short amount of time. Right, so let's go ahead and again, let's go ahead and set this. There we go, as ordered from the menu, a spiral. This is really great. You're still going to get some really big scallops, even if you tighten this up a little bit, because of these steep walls. Steep walls in 3D machining really can cause a problem. They leave these really weird scallops. There's a couple different ways to approach it, and really the name of the game is you want to do as much as the least amount of post work as possible, right? You want the machine to do all the work for you. That's why we're kind of going over all this. So let me go over that other one that's going to do a little bit better here, and it's going to be radial. If we go into advanced settings, you can see exactly this, not exactly the same, but you can see we have the center, the angle that it's going to go, so we can just do it from 90 degrees, but we're going to do it all the way around, and then our min and max. So let's check this one out and see what this one looks like. Again, as promised, there's our radial tool path starting from the middle and radiating its way out. Radiating its way out. This is really good for round parts like this, dog bowl parts, looking parts, anything like that that have, kind of a really steep wall that kind of come down into a center, especially round parts like this, obviously. That's pretty much lace cut. I think we pretty much beat that to death. So I really want to show you another really, really great option in GibbsCAM. And that's going to be our Constant Stepover tool path. I have this mold here that I need to machine, and I have all of these really kind of funky surfaces. And as we're talking scallops, you can imagine that if I just went over this whole thing, I'd end up with these really bad scallops around here. So what I would like to do is have a tool path, let me move this over a little bit, that's going to follow not just the outer contour, but also on the floor of this, right? And you guessed it, Advanced 3D does it. Move this over so we can see it a little bit better. There we go. So here's our constant step over cut, and really that's what I'm looking at right here. So I want to do constant step over cut. So here I have my constant step over. Here's how big I want my step over to be. Again, it's going to be a little big, but it's just for demonstrational purposes. I click on the surface and just click do it. So that looks pretty good, right? Kind of goes over. There's some retracts there that we can change. So here we can do that in our entry exit. That kind of gives us these little arc moves that go in there. So here we have axial, vertical, or both, how you want the arc to be, how it's coming in, trimming. But really what I wanted to show was over here. There's a couple things, right? We can remove spikes and connect move control. We can do angled or shortest, and we're going to go ahead and say shortest. That looks a little bit cleaner. It's nice. So we changed a few things, and as we go through any 3D toolpath, really any toolpath. We're changing settings. We're looking for optimum feeds and speeds. We're looking for optimum stepovers. You know, there's a lot of stuff that we know, that's why we're machinists, to change in these menus. What I found over the years is, you know, a lot of programs, I end up doing the exact same thing over and over. Change this on every single thing. Change this on every single thing. In GibbsCAM lets you save processes to reuse. And I'll show you how this works. Let me go ahead and close this out. So I'm going to right mouse button click right on this process. And you can see that we've got a couple things here. And I'm going to say, you know what, I'm going to save this process list. And I'm going to go ahead and save it on my desktop. There it is. And just hit save. So there's nothing here. Here's my tool, right? Here's my tool path, everything. Let's go ahead and click off of this. So now what I want to do is I want to apply that tool path. Let's say this is another shoe mold that came into the shop. I've already done it, right? I already know the feeds and speeds. I want to reuse it. All I do is I right mouse button click and I load a process list. I'm just go ahead again, go back to my desktop, pick that process, hit open. Holding down my control key, I'm just going to go ahead and click all these. There's a little one over there. And go ahead and click do it. Here you can see, here let me zoom in here, that it applied that same step over, you know, those same retracts that I used, the stay down, all of those parameters that I changed, it used in this toolpath. Now that we went over roughing and a couple finishing routines, let's go ahead and put it all together. Let me open that model up. On this model, I'm just going to apply the adaptive roughing that we went over and that constant step over finish pass. This is by no means finishing the part completely, but it'll give you an idea about applying these saved processes in GibbsCAM. So let's go ahead and we're going to open up a process that I actually saved before it for adaptive roughing. Let's go ahead and open that up. We can see as soon as I do that, it throws the appropriate tool in the appropriate spot, and also applies this process. Just to make sure, I want to make sure that all of my zeros are set in the correct orientation. Now all I have to do is select the model. Let me turn on solids, select the model, and click do it. Looks good to me so far. Next, we're going to go ahead and just put in that process that we actually saved for that constant step over, this one here. And all I have to do is choose the surfaces. Again, I'm going to use those select surfaces commands. So I'm going to select faces above. I'm going to hold down my control key, do the same thing. And now for this one, I'm going to say select tangent faces. Just missed a couple up here, holding down my control key. Just click those and we're good. So let me open up the constant step over. I'm not going to rough it at the same time, so I'll delete that. So just to make sure that all of our settings are set, and just like every time, click do it. In the shop, you would probably run both of these processes simultaneously, the roughing and the finish. I ran them separately here for the demonstration of how to pull in a process. Now, I could have saved both of those in the same process and pulled that up and then just run the roughing and finishing at the same time. So just like that, we have all of that tool path on the part. We know that the speeds and feeds and the step overs are correct because we've already run it on another part. But we can still go ahead and look at that operation in OpSim So there's the really fast opsim. There's that adaptive that I was talking about. It's going down, making that big step, and then coming back up and cleaning up. Right after this, in about 2 seconds, it's going to go ahead and start that constant Stepover toolpath. There we go. Last but not least, I really wanted to show one really cool thing. I think I just have enough time to show machine simulation in GibbsCAM. So let me go ahead and I'm going to put this on a machine model so you can actually see the kinematics of the machine cutting this part. So in order to see this on a machine, instead of operation simulation, opsim, we're going to go down to the next one is machine simulation. I had the Haas machine preloaded for this part, so when I went to machine simulation, it automatically opens up this machine model. Once it's opened up, I'm able to manipulate it. I can spin it around, right? I can hide and show different parts of it. Let's say, for instance, the door. Move this over here so we can see it. I can just click this little eyeball here so we kind of get a better view of it. I can even hide the sheet metal if I wanted. Say both sides. We'll leave the back because it looks pretty. Let me zoom in a little bit here. There we go. And now we just hit play and it'll actually show the kinematics. Now there's not a whole bunch to see on this one because of the 3-axis. If this was a 5-axis part, you'd be able to see the 5-axis turning, the 4-axis, being able to see interference between not only the part and the stock, but also your fixtures, your head, even the nozzles for your coolant. This is a really handy thing when you're doing really deep pockets in 3-axis, or for sure if you're going to do 4 or 5-axis. So if you have any questions about anything that I covered today, from machine simulation to basic programming to advanced 3-axis, please reach out to your local reseller. We'd be happy to help you. Thank you so much.